All right, well, we're going to talk about binomial equations in this video. Now, a binomial equation has two terms. And what we're going to do with those binomial equations is we're going to learn how to factor, put a little star by that, and down below here, we're going to learn how to find the solutions. So in this video, we're going to focus on factors and factoring. So what does it mean and what does it look like to factor? Well, to factor something means we want to break it down. And so let's take a look at something like 21. Now 21 can be broken down into 3 times 7. 3 and 7 are the factors of 21 because 3 and 7 together multiply to 21. We could also have factors that look like this. Let's say we have, well, let's do this. X plus 3 and x plus 2. Now those are variable factors. And so we know 3 times 7 is 21 from the last example. But if we took x plus 3 and x plus 2 and we multiplied them, kind of review for you. And let's put x plus 3 here and x plus 2 right here. And if we use the box method and take x times x, that would give us x squared. And 3 times x is 3x, 2 times x is 2x, and 3 times 2 is 6. Then if we add the boxes together, that gives us x squared plus 5x plus 6. So kind of in a reverse order, we can say that x plus 3 and x plus 2 are factors of x squared plus 5x plus 6. Okay. So let's talk about a couple other things here that will help us in the factoring process, namely the greatest common factor, which we abbreviate often as the GCF. And the greatest common factor is the largest monomial that divides into each term of a polynomial. And I'll give you a quick example. Let's say that we have something like, I'll just pick this, 7x squared plus 21x. All right, well, if we look at 7x squared is made by a 7, an x, and an x. 7 times x gives us 7x squared. 21x, if we break 21 down, 21 is, there's our 3 and our 7 and an x. So 3 times 7 times x gives us 21x. So if we look at these sets right here, what do they have in common? Well, they both have a 7 and they both have an x. Therefore, 7x is our greatest common factor. Now, you've probably heard the term perfect square, and it doesn't deal with an actual square itself. It deals with a square of a number. And so let me define that for you. Perfect square is a number, or let's say variable expression made by a whole number or a variable squared. I'll give you a few examples. 9. 9 is a perfect square. Why? Because 9 is made by 3 times 3, or 3 squared. 121 is a perfect square because 11 times 11 is 121, or that's the same as writing 11 squared, as is x to the second, because x times x is x squared. All right. So then we've already talked about solutions in a previous video, but solutions, if you'll recall, are values of x that make y equal to 0. Remember, solutions to a quadratic actually are the locations where the graph crosses the x-axis. All right. So let's factor a binomial. And there's two ways in which we can factor a binomial. And the first one that we're going to look at here is, and we'll do this in green, is we're going to look at finding the greatest common factor. All right, so let's look down here today. So on A, I have 5x squared plus 10x. I want to factor that, okay? So what that means is I want to find what can I break 5x squared and 10x into, so that when I multiply those factors together, I get back to where I started. So I'm going to kind of do this the long way first. So 5x squared. Well, 5x squared is the same as 5 times x times x. Now, if I break 10 down, 10 is the same as 2 times 5. And I'd have to have an x to get 10x. Now, you'll notice that all the factors in terms of the numbers are prime, which means 5 and 2 both have two factors, one in itself, okay? So if we take a look at 5 and x and 2 and 5 and x, both of those have a 5 and an x. So what I'm going to do is I'm going to pull a 5x out. That's the greatest common factor. Now, I'm going to put a set of parentheses because here's what I have to think of. I have to think, what can I take 5x times that will give me 5x squared? Well, look right below 5x squared. I need a 5, an x, and an x. Well, right now I have a 5x, so that means I need the other x. Now I have to think, what can I take the greatest common factor, namely 5x times, to get positive 10x? Well, if I have a 5 and an x, all I need is a 2, right? So the factors, this is how I write the factors. 5x times x plus 2. If you multiply it out, is 5x times x 5x squared? Yes. Is 5x times 2 10x? Yes. Hooray, we've got it. Now, the second one on B, let's maybe not show as much of our steps this time. Let's just kind of look at it and see what we've got. So 6x squared and 4x. Well, I know 6 and 4 are both divisible by 2. So that means I can take a 2 out, and they both have an x, don't they? Okay, so what can I take 2x times that will give me 6x squared? Well, 2 times 3 would give me 6. And if I have an x, I need another x because x times x is x squared. So that part's done. Now what can I take 2x times to get negative 4x? Well, 2x times negative 2 would give me negative 4x. And if I wanted to break that up, I could do that. 6x squared is the same as 2 times 3 times x times x. And 4x is the same as 2 times 2 times x. So as long as I've got all my parts accounted for, I'm good. got that one done too. Let's move on. All right. So 10x squared plus 7x. Well, 10 and 7 don't have any numbers in common other than 1, but they both have an x. So if I take an x out, x times what would give me 10x squared? Well, 10x. And x times what would give me 7x, and that would be 7. Again, if I multiply x, which is the greatest common factor, times 10x plus 7, I should get 10x squared, and I should get 7x. So every one of these I can check, and so far, 3 for 3. That's the greatest common factor method. Now, there's a method called the difference of squares. Remember up top, we talked about squares and perfect squares a moment ago. So the rule says if we have a squared minus b squared, that factors into a plus b times a minus b. Okay, I'd like to take a moment here and just show you how that works. You don't have to write that down. Let me just kind of show you this off to the side here. Okay, so again, our rule says a squared minus b squared is equal to a plus b and a minus b. Okay, so let's use the box method to verify this. A and b could be variables like they are. They could be numbers as well. So here's a plus b and here's a minus b. All right, so a times a is a to the second. A times b is ab. A times a negative b is negative ab, and b times a negative b is negative b squared. Now look what happens. Those added together become 0. So the only thing we're left with is a squared minus b squared, which is exactly what we want. Okay. So here's what we're going to do. We're going to take a look at x squared minus 9. Well, x squared is really the same as x quantity squared, and 9 is really the same as 3 squared. So both terms in the binomial are perfect squares. Okay, that's important. Now, because of this, I can kind of think of my x as the a and the 3 as my b. So by this rule that I'll put in a red box here, x squared minus 9 is going to factor into x plus 3 and x minus 3. Okay, because the rule says a plus b times a minus b. Now I want to prove it. Okay, and you can do this every time. You don't have to, but you can. So here's x plus 3 and here's x minus 3. And if we get x squared minus 9, we've done it right. All right, here we go. So x times x, x squared. 3 times x, 3x. Negative 3 times x, negative 3x, and 3 times negative 3, negative 9. Look, you add them together, the 3x and the negative 3x become 0. All you're left with is x squared minus 9. We got it. Done. Okay, let's look at E. Stay with green. So x, again, squared is x squared, and 10 squared is 100. Perfect squares. Okay. So by rule, here's what we've got. We notice it's a difference of squares, so should be x plus 10, x minus 10. Do you trust it? Well, it's only the second time you've seen it, so you might be a little skeptical. So I'll prove it to you really quick. Look at that. Look at that. Middle terms, 10x plus negative 10x gone. X squared minus 100. You bet. All right, our final one here before you look at a couple. Here's F. Okay, 4x squared. Well, is that a perfect square? Well, actually it is. 2x times 2x would give us 4x squared. And 7 squared is 49. So this one should factor into 2x plus 7 and 2x minus 7. And it does. I could verify it with the boxes. Okay. As I'm losing things here, but hey, it's going to work out. All right. Well, gosh. Independent practice time. We got an x squared minus 16, x squared minus 16x. Look very similar, but a little bit different in how you factor. Give them a try. I'll be back in a moment with the results. Okay, let's see what you have. All right, right down here. How about x plus 8, x minus 8? Hopefully you're listening, because that's not it. That will not work. And how do we know that? Well, because I know the following. I'm just going to go ahead and take that away. Not needed. I know that this is the same as x squared, and 16 is the same as 4 squared, not 8. 8 times 8 is 64. So therefore, this one factors into x plus 4, x minus 4. The second one is x squared minus 16x. I can't use difference of squares here. I have to look at the greatest common factor, and you'll notice both of these terms have an x, which leaves behind an x minus 16. Okay? So when you're factoring, the first thing that you want to do is you want to look for that greatest common factor. If there's no greatest common factor, then you want to look for a difference of squares. All right? We'll be back in the next video. We're going to combine these, and then we're going to look at finding those solutions.